normal. Okay, we're going to talk about arc length first, okay? So arc length, we kind of spoke about it already, and we spoke about it in terms of degrees. So when I say arc length, I'm talking about the length of an arc on a circle right here. So for example, like this one here that I'm highlighting, arc length, right? And we measured it before, and if you know that this was a central angle, how would we measure that arc length in degrees? What would it be? It would be 90 degrees. You're absolutely right. Why would it be 90 degrees, Amit? You're totally right. Because the whole circle is 360, and you're making a quarter, right? This is 90 degrees, and the central angle is 90 degrees, right? So 90 degrees represents 1/4 of the entire circle. Is that true? Okay. But the question is, what if I told you that the radius was, say, 12 inches? The question then is, how long is it? Like if I was going to walk that, if I was an ant or something, right, and I was going to travel along the path of that arc, the question then becomes, well, how long is it? Well, we know it's 90 degrees. We know it represents 1/4 of the circle. But how do we calculate then exactly how long it is in inches, right? If we knew the radius was, it has something to do with circumference. What do you think?
You take a part of the or you take a portion that is equivalent to the degree of the circumference.
Yes, you are totally correct. So the question that we have here then is, how long is this, right? And it has something to do with the circumference, right? Well, what do we know about the circumference? The circumference is equal to what? Well, what's the formula for circumference of a circle? 2 pi r. That's the circumference of the whole entire thing, right? But we only want a portion of it, right? We only want 90 degrees of the 360 degrees, right? So what we do is we actually apply the arc length formula. I'm going to give it to you right now. So we're going to say arc length formula. Well, it would be x over 360 degrees multiplied by 2 pi r. So what do you think x needs to be in this case? What does the x represent in this case? X is in the degrees, right? So you take the amount of degrees that you have, where x represents the degrees, and you multiply it, or add a 360, and you multiply it by the circumference, okay? So this part right here, this represents the full circumference. And this part right here represents the degree that you've been given, okay? So, as an example for us, if we want to actually calculate this problem, I'll shrink it down and move it over a little bit so we can all see. We would say this. Well, we would say, well, the arc length would have to be 90 of the 360 degrees total, right? Multiplied by 2 times pi times my radius, which is 12 inches. So 90 over 360, that represents a quarter, right? And what's 2 times pi times 12? That would be 24 pi inches, correct? And then what's 24 divided by 4? So I have 6 pi inches, and that is how long that arc length is. 6 pi inches. We can leave it in 6 pi inches. If I wanted to if I was an ant and wanted to know exactly how far I would be traveling, I would then approximate my answer, right? That's a smart ant, a very smart ant. You're absolutely right. So if I really wanted to know like how far I'd be going, I would go 6 times, and I want to show you where the pi button is, everybody. Do you see the division sign right here where my arrow is? See the division sign? And then do you see the caret symbol above that? And then do you see the little tiny yellow pi? Yours might be blue or white. To activate that, I just go second, and then hit that caret button, and notice pi shows up. So that would be about 18.850 inches. So it would be approximately 18.850 inches. Okay? So this answer here, ladies and gentlemen, what do we call that? The 6 pi inches. That is the exact answer. What do we call this answer here? The approximate. So your question, which one do you leave it in, depends on what they're asking for. If they're asking you for the exact, which one are you going to pick, everybody? The 6 pi. If they're asking you for the approximate, which one are you going to pick? Okay, so it depends. So now look at that length there. If this is 12, then that represents 18.850. Okay, let's do this example here. We've got a 60-degree arc. We're trying to find the measure of arc A to B, and we're going to get both answers to the best we can. We're going to get the exact and we're going to get the approximate. So again, if I was a little ant and I was going to walk along the curve of that circle, or if I was going to take that highlighted part out of the circle and lay it flat on the ground, how long would it be? That's what we're trying to figure out. So we're going to use the arc length formula. So we're going to say the measure of arc AB has to be 60 of my 360 degrees. That's the part that represents, times 2 pi times the radius, which was given to be 18 centimeters. So 60 over 360 is 6 over 36, which is 1/6. Do you guys agree? Yeah. Times, what's 2 times 18? 36 pi centimeters. So if I divide 36 by 6, what do I get? I get 6 pi centimeters. Oh my gosh. Was that the exact same thing we got over here? Look at that. Boom and boom. Right? Inches, and then this one was centimeters. Kind of a bad example, but you get the point. Okay, let's talk about what a sector is. So the easy way is to say it's the blue stuff. Okay? But more precisely, the sector is the area of the circle. That is bounded by 2 radius. So 2 radii, right? And an arc. So the yellow part represents the arc there. So it's the blue stuff, the stuff in there, okay? And we want to calculate how much of that blue stuff is actually shaded in. Now, it's not the entire circle, right? It's only part of the circle. So if you take the idea of what we did up here with the sector, look what we did. We did something divided by 360 and then multiplied it by circumference. What do you think we're going to do here for this one? You got it. So the formula then for us is going to be the area of the sector is going to be x over 360, and that's your degrees, whatever you've been given, multiplied by, instead of circumference, we're going to multiply by area. What's the area of a circle?
Radius squared times pi.
Pi r squared. There you go. So we're going to choose to use this one to figure out the area of that sector. That's the formula that we're going to use for that. Okay, so there, we run into a small problem here, okay? If there was no picture, and I said sector, and I said arc AB, you guys would choose the minor arc, right? Because we know that there's minor arcs only have 2 letters in them. But if I say what's the area of the sector, and you see a picture, and it's a shaded one, that could also be considered sector AOB, right? So this is sector AOB, the entire sector there. And it's bigger than 180, right? So you have to either have a picture or be told what the measure of the angle is. Okay? Nope. So we'll just say sector AOB. That's what we're looking for. So we're looking for the blue stuff. So you will either be given a picture, in this case we are, or you will be told the measure of angle of sector AOB is equal to something, and then you can draw it in. So it will be given to you. Alright? So with that out of the way, we can then solve for the blue stuff, right? So I'm going to say the area of my sector, area has to be the degree I've been given, 240 out of my 360, which makes sense because it's definitely more than half the circle, so it should be bigger than 180. The blue stuff takes up more than half the circle, right? And then we're going to multiply it by pi radius, which is 15 squared. Fair enough? Let's simplify that fraction. Cancel my zeros. What's 24 divided by 36? 2/3. Very good. I have 2/3. Multiply it by, what's 15 squared? 225 pi. And this is centimeters. Good. So what's 2 times 225? No. $2.25. 450. Very good. I thought I heard something else. Okay. 450 pi centimeters, all divided by 3. What do we have for an answer here? 150 pi centimeters squared, cubed. What do I do? Squared. Do you guys get the same thing I got?
Yeah, we did.
Okay, there we go. All right, so let's draw an AOB. Okay, here's A, here's O, there's B. I know two things about this. What do I know?
The inside is down.
Yep, I know that this right here is 9 degrees.
The rest is 300.
Well, I also know that's true. And I also know the area of that sector is what? 5 pi over 8.
But what I'm saying is, how was I supposed to know if the thing be so close to each other?
Because it's only 9 degrees. How big is 9 degrees?
It's not that big.
9 degrees is pretty small, right?
Yeah, but what I'm trying to say is, how come we use like 351? Or because they asked for that one?
They asked for that one, right? We're looking, what is our goal for this problem here? What do we want to do? We want to figure out the radius, right? That's what we're trying to figure out, okay? So, here's what I know. I know the area of a sector is x over 360 multiplied by 2 pi, times pi r squared. I know that's true, right? And what was I given the area of the sector to be in this case? 5 pi over 8. So I can put 5 pi over 8 on the left-hand side. That's equal to x. X stands for the degrees. If my central angle is 9, that means my arc length angle is also 9. So I'm going to have 9 over 360. And I'll multiply by pi r squared. What am I being asked to find? The radius. So do I have an equation that only has a radius in it?
Yeah.
I do. So I'm going to move this up and focus on that equation. I'm trying to find what? What am I trying to find, everybody?
The radius.
The radius. Very good. So first things first. Let's see here. Do you agree? I could write this like this. 5/8 times pi equals 9 over 360. Can I simplify that fraction?
Yeah.
What would it be?
1 over 40.
1 over 40. Good, I agree with that. Times pi and then an r squared. You guys cool with that part? Okay, do you see that the pi's now cancel out? Do you see that? Okay, good. So now you're left with this. 5 over 8 equals r squared over 40. Does everybody see that algebraically? Because 1 over 40 times an r squared is r squared over 40. Just multiply them up. And now I can cross multiply. So I'm going to move this up some more to about here. So I get 8 times r squared is equal to 5 times 40. What's 5 times 40? There we go. 200. Now what do we do? Divided by 8. So r squared must be 25. Oh, this is looking good.
Wait, why'd you put everything over? R equals 5.
Cross out my 8s. Do my algebra. So therefore, r must be the square root of 25, which is 5. And in this case, what was I given? I was given inches in my problem, so I have 5 inches. So there's the problem from start to finish.
Wait, stay there.
Yeah, you can see everything.